Hi, I'm Mihir Dhamankar.
And I am Murphy Austin, and we are presenting our final project, which is obstacle assistance for the visually impaired. So the problem that we're solving here is creating an application that serves visually impaired users, specifically for identifying overhanging objects that are potential obstacles. So visually impaired people can use canes for ground level objects, but for overhanging objects, we are creating an application that runs on a Google Glass, which is a mobile device that you wear on as a glass, and it has a camera and audio output. And we're implementing an app that runs on this and also on a cloudlet server. An app that produces alerts for visually impaired people when an impending overhanging object is coming. I'll hand it over to Mihir, who will talk about some of the existing work.
So, in terms of existing work, there's a lot of research about virtual acoustic displays for blind people to navigate. So, one thing that it goes into is spatial audio using HRTFs. So, these head-related transfer functions convert a point in 3D space to a binaural audio signal. So we've used this, doing these calculations is quite difficult on the glass itself, so we offload these to the server, and this has various advantages. And then on the server itself, we use OpenMiDaS, so the MiDaS ML model and the Gabriel system to take in and process this data.
Just to quickly run through our solution design, we have a Google Glass that is receiving video input. It's sending this input directly to a cloudlet server that is nearby, and the server is doing the processing and object detection as well as the generating of audio alerts. And then the server streams back audio for the Google Glass to output. So the server is doing all of the computation here, and the Google Glass is just a very thin client that's doing input and output. We addressed some challenges here about the programming environment and resource constraints of the Google Glass by exporting all of this computation function to the cloudlet. And we also tackled doing audio generation in a container-based environment and doing object detection using a relative depth map. Our results, we found we had consistent detection of objects within 5 feet of the user, and we had low battery drainage on the Google Glass device, which was a major goal. So I think maybe that wraps up our poster section. Thank you.
Okay, so this is the Google Glass device we're using, and basically it has a small camera. You can see it's on there. And what it's doing is taking the camera feed, which can be seen here. This is the feed being sent to the server. The server is then detecting if there's an obstacle in the way, sending back the audio that it generates, and then that audio goes to the Google Glass again, and then is outputted right now through this speaker. Usually through, it'll be through headphones because it's like binaural, so you get two, like a left and a right signal, and you can localize where the obstacle is coming from. So I think Murphy can explain exactly how this is happening.
Cool, yeah. And this is a visualization of what's happening on the server side. So the server is accepting the raw input frames. It's applying the MiDaS ML model to generate a relative depth map. And then it does a series of cropping and object detection algorithms to isolate the space in front of the user and to detect whether an object is present and to get the coordinates at the center point of this object. And it's these coordinates that are used to generate the directional audio that is then streamed back to the user.